Alright, so now that we have the various maps exported from this Rhino, let's now begin the process of exporting the geometry from Zbrush, and then we'll take a look at reassembling this Rhino back in our primary 3D package. In this lesson, we're going to take a look at reassembling it in Maya, and then we'll take a look at the process in XSI. Alright, so here's the Rhino with all the detail that was sculpted into it. So to begin the process of exporting the geometry, we can do one of two things. If you had exported the normal maps, or the displacement maps rather, from the morph target, which we had talked about in the previous lesson, then you can go ahead and reassign those maps back to your existing geometry. There's really no need to export it, since the maps should match perfectly the geometry that came in. But if what we did in the previous lesson, if that's the method that you followed, where you exported the maps from this altered geometry, we need to get that geometry back into our primary 3D package. So the first thing we need to do is let's go to the geometry, drop down the subdivision to its lowest level, and then export the geometry as it exists right now. So we'll go up to Tool, Export, okay, and let's call this something like Rhino Zbrush Export. Okay, we'll go ahead and save that, and now we can take this geometry back into our primary 3D package. Alright, so we're going to use Maya for this particular lesson. So to begin this process, we'll go to File, Import. Alright, and we're going to point it back to the OBJ file that we just exported, this Rhino Zbrush export. Let's go ahead and bring that in. Okay. So we'll go ahead and frame in on this. Now you can see that the geometry comes in with these really sharp edges. So the first thing I always try to do is take this geometry, and we'll switch back to the polygon menu. Go to Normals, and let's soften these edges. There we go. And so now you can see that soften that up, and that'll help really smooth this out once it comes time to actually apply the displacement maps and the normal maps. So let's get started by assigning the materials that we need. So let's go to Create Maya Nodes, and let's start with a simple blend. First we'll start by connecting up the displacement map. So we'll create a new file. Alright, and we'll go ahead and connect it to this displacement map that we just exported in a couple lessons previous. So we'll connect this. We'll give this just a moment to load up. Alright, very good. So now we can take this map, middle click, drag it onto the blend, and connect that as the displacement map. Okay, so now we'll take this blend, middle click, drag it onto our Rhino, and when we render this, we'll make sure we render it with Mental Ray so it can take advantage of some of the subdivision powers that Mental Ray has. So we'll switch the renderer to Mental Ray and hit render. Alright, and you can see the result that we get back is not quite what we would expect. You can see everything's just a little bit puffy and very inflated looking. Now the reason is the displacement map that Zbrush exports. You can see that for the most part, if I go ahead and collapse this, that this map is mostly gray. Now, Zbrush reads 50% gray as having no displacement. Now, most other 3D applications read 100% black as no displacement. So what we get whenever we try to apply this in something like Maya is it reads all this information that is not supposed to be displaced as actually having some displacement applied to it and being pushed out. So it's actually a very simple matter to fix. All we need to do is just remap some of these colors. Now that can be done if we go and double click on this so that we open up the displacement map and take a look inside the color balance. So in this we can find the alpha gain and the alpha offset. These are basically controlling the black and the white values of this displacement map. So typically, what is a good idea to do is to take this alpha offset and set it to a negative 1/2 value of whatever the alpha gain is set to. In this case, the alpha gain is 1, so we'll set the alpha offset to a negative 0.5. And what that will do is at render time, remap this 50% gray to 100% black. So let's take in comparison. Let's save this, render out a new image. And there we go. So that's a little bit better. And you can really see, without any sort of adjustment to the geometry itself, that Metal Ray actually does do a pretty good job of applying all the detail from this displacement. Now, looking at this, the displacement is probably a little bit too strong. You can see it's definitely pulling out and pushing in, probably a little stronger than it needs to. So that's, again, a very simple matter to fix. What we need to do is just simply drop this alpha gain to a lower value, so that way these white values are not quite so intense. They won't pull up quite so high. So let's maybe try dropping this in half. We'll take the alpha gain to 0.5. Now remember, the alpha gain has to be a negative 1/2 value in order to map correctly. So we'll try negative 0.25. So again, we can save a comparison. There we go. Now you can see that's quite a bit more manageable. So, as mentioned, without really a lot of adjustment on this, the Metal Ray displacement approximation does a really good job on this. But you can see there are a few little problematic areas. You can see maybe where the geometry is not quite being subdivided to the point where it needs to. So what we can do is apply a render time displacement or a render time subdivision to help smooth this out a little bit more. So let's go back to the geometry and let's apply this effect. So to do this, first select the geometry and go to Window, Rendering Editor. Underneath Metal Ray, you should find an option for the Approximation Editor. Now the Approximation Editor is basically Metal Ray's render time subdivision. So we'll apply this. What we want to do is a subdivision approximation, so that way it'll smooth this geometry or subdivide it at render time. So with this object selected, subdivision will create. Okay, doesn't really look like anything has happened, so what we need to do is edit this approximation. And this is what will control how many times this geometry will be subdivided. And we have several different types to choose from based on length of polygons, based on spatial distance, based on polygon curvature. For this particular instance, we're just going to use parametric. Okay, so let's move in a little bit closer, because we are going to run into an issue right in this area. Okay, so let's take a render of this. Alright, now you can see a couple of things have happened. Number one, the geometry is not nearly as detailed as it was in some of our previous renders. And we also have some of these little problem areas, these little flattened out spots. Now, the cause for this is that Metal Ray in Maya, the subdivision approximation, sometimes has difficulties dealing with geometry that has both quads and triangles in the base mesh. So if you look closely, some of these problem areas, you can see right behind the arm and a couple of rows back, actually correspond to where we have some triangles. You can see these two areas correspond perfectly to some of these problem areas. And also, right up along this area of the neck, you can see where we have a triangle. We also have a problem area here. So what we need to do is take this geometry and actually do a little bit of conversion on it to make sure that it's all quads at render time. So that way this subdivision approximation won't have any more problems. So just select your geometry, and underneath Mesh, we'll go to Smooth. And we'll take a look at the options just to make sure everything is set correctly. Okay, everything looks good. We'll go ahead and smooth the geometry. Now, once this has been smoothed, what will actually happen more often is it'll take any sort of triangles, any sort of polygons that have more than 4 sides, and we'll normally convert these to where they are now all completely quads. So this is a very quick, very easy way of getting rid of any kind of a base mesh that has both quads and triangles. And now you can see we no longer have any more of those problem areas. So a lot of times what I try to do is take the displacement map and try to subdivide the geometry just enough to where the displacement is able to pull out some of these larger features. What you'll notice is the more times you try to subdivide your mesh to get this detail, the longer your render is going to take. So I try to only subdivide my base mesh usually just like 2 or 3 times to just get the detail that I want, and then what we'll do is use the normal map to pull out some of the high frequency detail. So if you need to be able to access the subdivision approximation that we just used, a quick and easy way to do that is to open up your outliner. That can be done with this shortcut over on the side. And in your outliner, if you right-click and turn on Show DAG Objects Only, or rather turn this off, what you'll now have access is pretty much to all the different nodes in your scene. And if you look, here's the subdivision approximation that we had applied to that geometry. So if we double-click on this, now that we have actually subdivided this base mesh one time, we really don't need to subdivide it 2 more times. In this case, probably 1 more subdivision will do the trick. Alright, so you can see we overall have a little less detail. Still a very fast render though, only 11 seconds. But it's just enough to pull out some of these larger areas of detail. So this larger wrinkle, some of these larger areas around the underside of the arm. And also, we should have some of these large wrinkles around the neck that are also able to be pulled out, just enough by the displacement map. Okay, so now to pull out some of this high frequency detail, let's connect in the normal map. So we'll go to File, make a new file node. Alright, and let's connect in the normal. Alright, so there's the normal map. Let's take the same blend, middle click on the normal map, middle click, drop it over, and connect it into bump. So here's our bump node. Now in order for this to work correctly, we need to take this bump node that's bridging this connection and tell it to use it as a tangent space normal map rather than a bump map. Alright, and for this tangent space normal map to render out correctly, we need to make sure that we are using Mental Ray as the renderer. So let's take a comparison of this. Let's save this, hit render, and now you can see all the extra detail that was captured by that normal map. And you can see it only took an extra 3 seconds to render all of this. Now the reason is because this normal map is not actually subdividing the geometry. The normal map is just creating sort of an illusion of all this detail, but it doesn't actually require us adding any extra geometry. So if you compare what we had before without the normal map to what we have now, you can see how much of a difference that actually makes. Alright, now if we decide that this normal map is maybe a little bit too strong, we can always just take the bump depth and start to lower this. And just make some minor adjustments to that until we find the values that we want. Alright, so that's a look at how we can start to reassemble all of these things back within Maya and how we can use just the normal map to pull out these high frequency details and use the displacement map to actually extrude and pull out some of these larger details. So we use each map to use just what it needs to do. And that way we don't have to spend a lot of render time just using the displacement map and having to subdivide this mesh so many times that we have to wait on these really, really long renders. Right? So that's a look at reassembling this back in Maya. And what we'll do in the next lesson is take a look at this same process but using XSI.